So we're now going to look at the recurrence relation for compound interest. So again, I've got another Excel document here that outlines what is happening each time. This particular case is looking at when we have a principal of $3,000 and an interest rate of 2.3%. This is assuming that this is compounded annually, and we're going to look at different compounding periods later in the video. So when we have compound interest, it's different to simple interest, because what happens is you find 2.3% of the principal, that's the same, and then you add that on. So the first year looks no different. Simple interest and compound interest in the first year looks very similar. What we then do though with compound interest is instead of taking 2.3% of the principal again and adding it on, we actually add on 2.3% of this new amount after 1 year. And then so that's what happens here. We are actually increasing by slightly more now. And then what we do is we find 2.3% of this yellow highlighted value of $3,139.59. And we find 2.3% of that and add it on, and that will give you the next value here. And this keeps happening. So we keep finding 2.3% of the previous amount and adding that on. So to write this as a recurrence relation then is going to look a little bit different, because it's not just adding a fixed amount to the principal every time, or the fixed amount to the previous term every time. We can see that what we're adding on every time changes. We can see that in these numbers here. So to figure out what that value is going to be is we have to figure out, well, what is happening from term to term? Well, from term to term, what we're doing is we are actually multiplying by 1 plus our interest rate every time. And that means that we are multiplying by 1.023 in this instance every time from term to term. So if we were to write a rule for this, our general form, we can see that our A0 is still going to be our principal. That has not changed. We still start from the principal value. But our recurrence relation, AN plus 1, is going to be equal to the previous term multiplied by 1 plus I. And that's going to basically increase the previous term by, in this case, 2.3% every time. So you're just kind of increasing it every time from term to term. So if we have a little look at this question, it says Ewan deposits $3,500 in a bank account that pays an interest rate of 3.2% each year. Construct a recurrence relation for this financial situation. So what we're going to see is that our initial starting point is going to be our principal value, which was 3,500, and our recurrence relation, AN plus 1, is going to be equal to AN times by 1 plus I. And remember, I is the decimal equivalent of this. So I is going to be equal to 0.032. So just writing that out in a neater form, we're going to get 1.032 times AN. And that is our recurrence form. Okay, this next question, going to be a calculator question, this one. It says the following recurrence relation models a loan of $4,000 that is subject to compound interest at a rate of 6.4% per annum. Use the recurrence relation to find the balance after 1, 2, and 3 years. So we first of all need to construct the recurrence relation. So we need to say, well, A0 is my principal, $4,000, and AN plus 1 is going to be equal to AN times by 1 plus I. And remember, I is the decimal equivalent of this percentage, which is 0.064. So simplifying that out, we're going to find that AN plus 1 is equal to 1.064 times AN. So to do this on a calculator then, it's going to be very similar to how we did the simple interest. We actually start by entering our principal into the calculator and just pressing enter. That has stored that now as our new answer value. We now need to have the calculator work out the sum of 1.064 times this value. So I'm just going to press times 1.064. And this now is just going to do the previous answer, always times this interest rate. So to find out what the balance is after 1 year, it will be 4,256. Then after 2 years, it will be 4,528.38. Remember to round to 2 decimal places with money. And then after 3 years, it will be $4,818.20. Okay, so for part B, it says how much interest has been charged in total after 3 years. So to work this out, let's write out our values first up. So let's just get this one up again. We have A1 equals to $4,256. A2 equals to $4,528.38, and A3 is equal to $4,818.20. Okay, so to work out now for part B, how much interest has been charged in total. So these are the total amounts. We want to say what is the interest that's been charged. Well, what we're going to do here is we're going to do A3 minus the principal A0 to find out how much has actually just been, that's come from the interest, not from the, we need to remove the principal from this. So this is going to be our $4,818.20 minus our principal of 4,000, which means then interest charged after 3 years is equal to $818.20. The next question, slightly different, says how much interest has been charged after the 3rd year. So what we're trying to do now is just say what happened when I went from the 2nd to the 3rd year. So how much interest has been charged. So to work that out, what I need to do here is to actually say, okay, I need to work out then what, so this is the formula, I'll just show you over here. So the interest earned or charged after the nth year, so that is what we're looking at, is AN minus AN take 1. So you just subtract away the term before. So how much interest has been charged after the 3rd year? So it's going to be A3 minus A2. So that's going to be our $4,818.20 minus our $4,528.38. So if we do that on our calculator, we type in 4 we get a total then of interest charged during this year of $289.82. So that's how much interest was charged in the 3rd year. So the next question then just says determine when the balance of the loan will first exceed $5,000. So to work that one out, what we're going to do is just go back to the start. So we're just going to type in our recurrence relation. So it's 4,000, enter, times 1 point, and it was 0.64. So the interest earned after 1 year, 2 years, 3 years, 4 years. Okay, so we can determine that when the balance of the loan will first exceed $5,000. It is in the 4th year. So we can write that out. So D, the loan will exceed $5,000 in the 4th year with a value of, and the amount it came out as was $5,126 and 57 cents to 2 decimal places.